All right, so we're going to get going with iteration first of all, just because that is the base process that we're going to be using at least for moving on to non-static rotations. So actually, I'm going to move that up in the order. Iteration. What is iteration? As you might know from like a design process, iteration is versioning, is changing something over time. And that is specifically what we're going to do. What we're going to be doing is we're going to be changing the value of a specific variable. So first thing, we need to declare the variable that we're going to change the value of. So making our way over to our P5 sketch here, the first thing we want to do is we want to declare our variable. So I'm just going to say let iterator equals to 0. So we're going to both declare the variable and we're going to initialize the variable. Initializing a variable, once again, means that we're going to assign an initial value to it. And I'll make a comment to say so. Declare and initialize a variable. And what's important about initializing a variable not only is that we know where we're starting from, but also that the variable now has a set data type, right? It's not a string, it is a number type of variable. Specifically, this will be an integer, but that doesn't matter so much. So now, next step is we're going to save our work. So I'll just say iteration and rotation. Okay, so now I can save. We're saved. We're all good. Next thing, we want to look at the value of this variable. So in our draw function, which once again is going to loop over and over and over and over again, we're going to use our console.log function, method to print out the value of that variable. So we'll just say console.log iterator. And remember our semicolon at the end there. So now that it's saved, I'll run this, and nothing exciting is going to happen in the canvas. All that we're looking for is down here in the console. We're looking for this 0 to be printed repeatedly. And so now, what we're going to do, let me just make sure nothing bad is happening in the chat. Okay, good. We need to modify the value of that iterator. And the way that we're going to do that is what's called an increment. So we are going to use a little symbol called ++. Well, not a symbol, but a little bit of code where we just write 2 pluses after the name of a variable. So when we say iterator++, this is going to add 1 to the value of our iterator variable. So now if I run this, what we're going to see in the console is going to be slightly different. We're going to see something counting up. So I'm just going to stop that because it counts up really fast. It counts up about 60 times per second. So it's faster than we can see it really happening. But if we look here, now we see 0, 1, 2, 3, 4, 5, blah, 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 all the way up to 136 before I stopped the code from running. So that means that our draw function in that short amount of time had run 136 loops. And so right now, this is still pretty boring, right? We're just seeing a number increase in the console, but we can use this. So really quick, let's before we use it, let's get something on screen. So I'll start out with my favorite, an ellipse. And I'm going to put it right at the center of the screen. So I'll just, I'll do it, I'll hard code it at this point so it's kept simple. So our canvas is 400 pixels by 400 pixels, which means right? If this is 400 and this is 400, then that means our center point is at 200 pixels in both axes. So that means that my parameters for this ellipse will be 200, 200 to put it right at the center, and I'm going to just make it 50 pixels in diameter. All right, very nice. And just for fun, I'm going to make it yellow, since what we're going to be doing is we're going to be making a little planetary system. I don't know if anyone watched the Mars rover landing, but that was, speaking of planets, that was pretty cool that it didn't crash. Okay, we'll make this yellow. So yellow is made of red and green and no blue. All right, and I'm going to get rid of that stroke with our no stroke function. And so that will make it so we no longer have a black outline on anything that we draw. All right, so we have a sun, and I'm going to change the background, since we're doing space, to black. So I'll just change that 220, which is giving us this gray, to a 0. And when my code, and now I have a sun hanging out in the void of space. So I'll save this. Oops. Save my work. And so next up, we need to make a planet. So let's start out with a little planet. So I'll just keep it yellow for now, just to make things easy. Ellipse, excuse me, and I will put it a little bit off center, right? We don't want it right on top of our sun. We want it a little bit to the side so that we can make this planet orbit our sun. So I'll just say 250 in the x-axis. I'll keep it at 200 in the y-axis, and I'll make this one smaller. This will be 15 pixels in diameter. All right. Let's just, we'll change the fill just so it looks a little bit better. Mercury, we'll make Mercury look gray, so I'll make that, we'll just say 100. Oops. All right, let's see how that looks. Yeah, I think that looks all right. Maybe a little brighter. Yeah, that looks good. Okay. So as we said in our previous work, when we rotate around the origin. And that origin, by default, is in the top left, right? That's what we were dealing with translation to remedy. So if I were to try to rotate this planet around the sun, that means that I have to move this origin point from the top left. I have to move it down to the center. So that's going to mess up my ellipse positioning, but we can handle that as we go. So I'm going to use my translate function to move that origin point from the top left 200 pixels over and 200 pixels down, so that the new origin is centered on this sun. So this is going to move our little planet here off of the screen. So don't worry about that yet. Let's just implement it, and then we'll move our planet back. So we want to now move our planet back here. So that means that we're going to subtract 200 from both of these, right? Because no longer are we establishing its location relative to this point, but now we're establishing it relative to this point. So that means this will just be a 50, and this will be 0. And our planet should be right back where it was. And so this is where it gets fun. In our previous work, we had things centered on the point of rotation, so it's more of a revolution. But now, when we're doing an orbit, we have our center of rotation, and we have our planet off to the side. So then now we're going to have, this is our radius of rotation, right? So our planet is going to move to different positions centered around that point. And this is where our iterator comes into play. Because each time we loop through that draw function, right, we want this planet to rotate around that point a different amount, right? We want it to rotate a little bit, and then the next time we go through the draw function, we want it to be rotated to a different position so that we can build that illusion of animation of the planet making its way around the sun. So let's do a static rotation, and then we can make it non-static. We can make it dynamic. So rotate, we'll just start out with, let's do pi divided by 2, just so we can make sure everything is okay. And you see that's good. That's another position in the same orbit. But what we need to do is we need to, inside of these parentheses, we need to use our iterator, which is incrementing, which is counting up, 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 up. We need to use that to change the value of what's within these parentheses. So first thing we'll do, we'll just do it wrong first. We'll just say iterator times pi divided by 2. This is going to rotate far too fast, right? Because that means every time the draw function loops, which is once every 60th of a second, it's going to make a quarter revolution, or a quarter rotation. So now I don't know if this is coming through Zoom, but it's chaotic. It's very chaotic. It's just some flashing circles, which means that this number, we have to decrease the angle that it rotates each loop of the draw function. So I'll just try pi divided by 20. I'll slow it down by a factor of 10. And that looks pretty good. That might be still a little fast. So I'll try pi divided by 30. Maybe still a little bit more, 50. There, I like that. That looks pretty good. And if I wanted to, I could make this to scale. I mean, this is obviously not to scale. But I could go to like Wikipedia or whatever and look up the interplanetary distances and speeds of like how long a Mercury year is. But we're not going to get into that deep of detail here. We're just going to add a couple more planets. So this is where push and pop are going to come back into play. We don't need to put our translation inside of that push-pop boundary, right? Because every planet that we have is going to be rotating around that sun. So that's okay. All right, so that means that just our rotation is going to be inside of that push and pop, and our ellipse and our fill, right? So I'm just going to put a push before we draw Mercury and a pop afterwards. And if I run this, nothing should change. Everything's the same. But I can just copy this and paste it. And I'll add a couple comments really quick. And you see these numbers, they're still counting up. Because remember, if we think back to our unit circle, right, we have 0, which is in the same place as 2 pi, which is in the same place, if we rotate one more time, as 4 pi, 6 pi, 8 pi, 10 pi, any even number of pi, we've made another rotation. You can think of this, if degrees are still more comfortable for you, right? 0 and 360, you're facing the same direction. If you're facing one direction and you do a 360, you're back where you were originally. 720 again. So even though that number keeps counting up, that's why it's looping back to the same rotational location. Okay, back to our second planet. Our second planet is going to be a different color. Venus is generally drawn as orange, so let's give it 255 red, 200 yellow, and 0 blue. Let's see how that looks. And we will put it 90 pixels away from the sun, and we'll make it a little bit larger at 25. All right, so now we have, I'm going to make that a little bit darker, I think. So I'm going to modify the green channel. I'm going to make it 150, and I'll make this maybe 235. That looks better. Now we have another planet that is rotating in lockstep with our first planet, which is not what we want. We want this one to move a little bit slower. So all we have to do for that, we don't have to change anything about our iterator, because that's just clicking away like a clock. It's just telling us what's happening with time. What we want to do is we want to change this coefficient. Remember, a coefficient is something that's multiplied against another number. So we want to decrease this number. So, we want to decrease this number, which means increasing the denominator, the fraction. If we divide by a larger number, that'll make the overall number smaller. So we'll make that, let's try 70. Looking good. I mean, it's once again not scientifically accurate, but it's aesthetically pleasing. So to make a moon, let's make Earth really quick in here first. So I'm going to make a third planet. So I'm going to copy the code that I've already copied, that you have had the practice of copying here, and I'm going to say draw a third planet. And I'm just going to save it. I'm going to change the location of the ellipse. Remember those values inside of these parentheses, the parameters of our ellipse function. The first two are our locations. So I'm going to increase this to 140. And I'll make it a bit larger. And I'm going to make it blue. So no red, some green, and a lot of blue. All right, so I think that looks pretty good, although I need to modify the speed of rotation. So 90, there, that looks pretty good. All right, so what we have going on is we have this, now we have this body orbiting our sun. And if we want to have a moon orbit that, then now we need to establish another rotation and another translation, right? So just going to my paper here. All right, so if we have our canvas, and we have our center of rotation, our sun, and we have our planet. I'm just going to draw the one planet. So this is our 0 point, right? This is our planet. Our planet is being drawn. If we look at our code, it's being drawn 140 pixels over and 0 pixels up, right? And then we're rotating everything around this center point. So we have, all right, we have our planet revolving around the sun. So now, if we wanted to have a moon orbiting around that planet, for this moon, we need to have the center of this planet be our new center of rotation, right? And so we can accomplish this by nesting another translation and rotation inside of this push and pop, right? So after this rotation, and after we draw our Earth planet, we'll make a new line of code here. And, oops, inside of here, we're going to just start out with another push and pop. Because whatever we want to have happen to this moon, we want to only have happen to that moon. So what we're going to do now is we're going to translate inside of that push and pop. We're going to translate our new origin to the center of this ellipse. And so we're going to say now 140, 0. So we're going to move our origin 140 pixels over and 0 pixels up and down. So now this is our temporary origin. And so now we can just repeat the same process we did with our planet for this moon. And to do that, we'll make a fill. Let's say this moon will be gray. And we're going to make an ellipse. And this ellipse will be just a much shorter arm of rotation. It's not going to be anywhere near 140 pixels. Let's just try 30 pixels. And we'll say it's not going to be any distance in the second dimension. And we'll make it 5 pixels in diameter. Let's see how that looks. Okay, so you see, we do have this little moon following our planet around. That's a little too small. I'm going to make it 10 pixels. All right, we have this little moon, but it's not rotating because we haven't told it to rotate yet. So we'll add this rotation. I'm just going to copy that, paste it, and I'll make it a bit faster. Yeah. So now we have a moon orbiting around that planet, and so we're not altering the position of the ellipse, right? We're altering the rotation after we've set up that different arm of rotation, right? We have now our center, our sun, we have our first planet, and then we have our new center of that planet, and we have the arm of rotation of our moon. So, so there we go, and you can add more than one. We could add another push and pop inside of here if we had a planet that had more moons. Make it just 60. This is going to be... So now we have a planet that has 2 moons in the same way that we made a star that has multiple planets. This looks like it's going to have a collision pretty soon. Oh, bam.